the x-axis of motion. Depending on the accuracy with which the probe was centered with the index, this alignment procedure may require several iterations. The degree to which the straight edge must be parallel is dependent on the range of the cap gauge being used. In this case, the cap gauge analog output has a range of plus or minus 0.001 inch or plus or minus 25 micrometers. When the straight edge has been sufficiently aligned, the bottom half of the index is secured in place. In the first step, capacitance gauge data is collected as the x-axis traverses from 0 to 250 millimeters, moving the probe past the straight edge mounted to the stationary z-axis slide. The carriage speed is 25 millimeters per minute. The DTM controller samples the cap gauge and axis position data every millisecond. 2,400 samples are averaged to yield one data point per 1 millimeter interval of x-axis travel. At the end of the traverse, the carriage location and cap gauge data are written to a specified data file. For the second step, the index must be precisely rotated 90 degrees. The cap gauge assembly is moved clear of the index and straight edge. The index is unlocked, rotated 90 degrees, and carefully relocked. The straight edge is now nominally parallel to the z-axis. The position of the straight edge is checked to ensure that it is still positioned against the locating balls of the kinematic cradle. The probe is repositioned so that it again senses the reference surface of the straight edge. Effort is made to reposition the cap gauge such that it will probe approximately along the path probed in the first step. The capacitance gauge readings are then recorded as the z-axis is moved through its range of travel. Note that in this step, the straight edge is moved past the probe mounted to the stationary x-axis slide. After the two straightness measurements have been performed, each set of data is processed to obtain a least squares fit line through the data. Remember that the sign conventions of the machine axes and the cap gauge voltages must be maintained. Ideally, the angles of the two lines with respect to the plots abscissas would be equal, and the angle between the two lines would be 90 degrees. If the angles theta 1 and theta 2 are not equal, the angle phi will deviate from 90 degrees and can be calculated with the equation shown. Remember that the squareness measurement is actually a comparison of the angle between the two mean axes of motion and the 90-degree interval through which the precision index is rotated. If a highly accurate index, or one with well-characterized errors, is used, this deviation from orthogonal can be accurately measured. In this lab, we have demonstrated the procedure for squareness of motion measurement. We have discussed how the nominal squareness is defined as the angle between the least squares center lines of the straightness data sets for the two axes of motion. We notice that the error in the straight edge is not removed from the straightness data as it is in the case of reversal, giving rise to possible measurement error. Furthermore, we observe that this angle is measured relative to the 90-degree angle through which the precision index is rotated, noting that this is yet another measurement which involves comparison to a reference standard. Each student will receive two data files representing the two steps in a squareness measurement. Included with the files will be information describing the measurement parameters such as carriage speed, sampling rate, and averaging. The homework assignment involves the following procedures. First, manipulate the data either manually or computationally to obtain the two straightness curves. Using a least squares method, determine the angle of the mean straightness line for each curve. From the angles, calculate the squareness error. Identify sources of measurement error and recommend further tests to better characterize the squareness of the two axes of motion. The lab write-up should again follow the standard format consisting of the objective, procedure, results, and conclusion. The write-ups must be typewritten or legibly handwritten. These write-ups are due at the beginning of the next lab.